Okay, today I'm going to show you how to calculate the normal distribution on Excel, right? First of all, uh, we learned the standard normal distribution, which means it is a normal distribution specifically with the mean equals to 0 and the variance equals to 1. But we are going to use computers to calculate the normal distribution. So actually, computer can handle any mean and any variance, but still, I believe that you need to understand the normal distribution. So it is not just about computation. Still, the standard normal distribution is important because we are going to compare like different random variables, but still the standard normal distribution is the standard, right? So we are going to compare different random variables. In that case, everything will be scaled back to standard normal distribution. So it is very useful in many practices. Also, like when you like think about some random variable, and if its scale is say billions, trillions, then you cannot understand how much outlying the outcome is or where is the mean. The idea, your intuition may become vague. But in the standard normal distribution, we know the mean is 0 and we know standard deviation is 1. So everything is scaled. It's like kind of the standard, measure. For example, when I tell you, like say, um, I'm in, like, so today it's like 50 degrees in Fahrenheit. But when I say, like say it is say like 10 degrees in Celsius, then you need to convert it to the Fahrenheit to understand how warm it is. So like in statistics, the standard is the standard normal distribution. So to understand your to develop your intuition, it is important to learn the standard normal distribution. And also later, we are going to develop a lot of theories based on standard normal distribution. So we are going to use the standard normal distribution to interpret theoretical outcomes later. So that's why I'm going to show you only the standard normal distribution. Still, if you want, you can just learn how to calculate probability for any generic normal distribution that is not standard. That is possible and it's pretty easy, but I don't recommend that for now because it is not about computation, but it is about developing your intuition and understanding. Okay. Also, we are going to focus on the cumulative distribution function here because this is a standard in statistics, and like any statistical software will calculate the probability based on the CDF, right? So there are many user-friendly calculators. That is true, but underlying them are cumulative distribution function. And if you need to learn like higher level softwares, they may not provide anything other than cumulative distribution function because this is the only information you need to calculate any probability. So again, it is not about just calculating probability, but to train you toward the standard and the convention that's used in practice, in softwares, and in theoretical statistics. That's what you're going to do. So, especially, we are going to think about 4 different types of probabilities, which is pretty much all. Say, first, cumulative probability, that is the basis, right? So that means we are going to calculate probability smaller than something, smaller than a value A. And then, if you flip the inequality, we may calculate the upper tail probability of this form, probability greater than A. Of course, by the way, Z here is the standard normal distribution. Interval probability is probability between 2 points. Okay, when you know A and B, let's calculate probability between them. And finally, percentile is, so here we are curious about this value. We know the probability, right? So what is, say, bottom 10% value or top 1% value, or what is like the median? So like say P probability is smaller than this value. What is that value? So it is a different type of question, and we are going to handle that in this video. So let's start from the cumulative probability. So we are interested in calculating probability z smaller than a, and of course a is a number, right? Then you are going to use the Excel formula of this form, right? So norm.s.dist is the formula, and you need two inputs, right? So of course norm means normal, s means standard, dist means distribution, right? This is how the formula is named. And then there are two inputs you need to enter, right? For the first input, you have to include the value of a, right? The point where you want to calculate the cumulative probability. And the second input is yes or no question. So you have to write true or false. If you say true, it is cumulative probability. If you say false, that is the probability density, right? Anyhow, we are interested only in the cumulative probability. So this is the basic structure. So then, as an example, let's calculate this number. We are interested in probability smaller than minus 2.57, right? Back to Excel. Here, we'll go to the formula tab. Formula tab, and then I will choose insert function. Then you can just use norm.s.dist. Then there is norm.s.dist formula. Then it tells you two inputs. There are two inputs. You have to put number. So the first input should be a number. So I will input the number that I was interested in. And then second thing is logical. It tells you that true tells you this, false tells you that, but we are going to use truth, right? Because we are truly interested in the cumulative probability. So click yes. Then it tells you 0.005085. So I chose this value intentionally because this is the approximation to 5%. Okay, 0.5%, sorry about that. So minus 2.57 is an approximation to 0.5%, okay? And okay, so we learned how to calculate the cumulative probability. Now let's think about upper tail probability. We are interested in probability greater than something. Then I'm going to use the complement rule. We learned how to calculate probability smaller than a number. Then if you think about the other side of the probability, 1 minus that probability would be probability greater than the number. Okay? Okay, so it is pretty simple. That means, so let's practice probability z greater than minus 1.65, right? So then I can now, instead of clicking, I will just type it equals, you have to start with equal, norm.s.dist. You need two inputs, minus 1.65 and comma true. So if you enter it, it will give you a number, right? But this is cumulative probability. This is probability z less than minus 1.65. But we are interested in probability z greater than minus 1.65. How you do that? We are going to calculate 1 minus this probability. So it is this. Again, it looks familiar. It is 95%, okay, approximation. 1.96 is not 1.65 is also a common number that will give you these common numbers, right? Commonly used numbers. So then third form of the probability is the interval, right? So you are interested in interval between A and B, And then we have to transform this probability into two cumulative probabilities, right? So cumulative probability of the larger side minus the smaller side. This is how we do it, okay? Now then, let's practice this. For example, probability between plus minus 1.96. Okay, back to Excel. We are interested in probability between minus 1.96 and positive 1.96. We are going to do that. To do that, we will calculate two separate cumulative probabilities, right? So plus side, minus side, let's do that. So it's norm.s.dist minus 1.96 time, comma, true. It will give you this number. And another cumulative probability gives you this number. And then the interval is their difference. From the large number, subtract the smaller number. It is this one. So then again, you see some pattern, right? Intentionally I chose the number because this is the interval that contains 95% probability. Okay. So this is you will see this many times later for theoretical analysis. Okay, this was the third probability. Next, we are going to calculate the percentile, right? So we are interested in this question mark, but P is given. Now probability is known, but we do not know the value, right? So we are going to use a different formula, norm.s.inv. Here, inv is inverse, right? We are inverting the role between the value and the probability. In the previous questions, when you input this value, then you get the probability. But now your input is the probability, and you will get the value. So your input is now probability. Okay. So you have to input the p-value. So let's calculate the 10th percentile, right? So probability below a certain value equals to 10%, 0.1. So what is that value? Back to the form. So 10 percentile, it is norm.s.inv 0.1 will give you this result. So bottom 10% is minus 1.28 approximately. It's pretty another common approximation. So this is how you utilize Excel and how you calculate any form of probability. Okay. Good luck. See you.